Hey guys, so today we're doing word search, lead code number 79. Given an m into n grid of characters in bold and a string word, this be a target, return true if the word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same cell may not be used more than once. So it's basically a depth first or breadth first search, whichever one you want to do. I'm doing a breadth first search over here. um, so basically you are given an m into n grid of characters. M into n basically would mean that it's not going to be equal. You could have more breadth and lesser length, or vice versa. And you will have a target, so you will have to form a b c c e d through this grid. And once you start at a character, you can either move down, left, up, or right. So over here you can see, or if we start at the letter A, we have two options. We can go down or to the right. And if we go to the right, we have three options again: left, bottom, and right. But we've already covered left, so we won't go back here. And there's no point of going to F, because the next letter over here, A, B, C, is is C, so it's not F, so we'll be going to the right. Again over here we'll see that B is not something we can go back to, and the next letter is again C. So we will search between these two, which one is C, this one is C, so we can go here. If at any point, say this was F and the next letter we wanted was E, and from here we cannot reach an E, then we would just terminate over here and just go back one step and see if there's any other C's we can reach from here. So the intuition is that we can, if the target word starts with a character A, we will be finding where that character is in the entire grid. So we can find that in this entire grid it's here twice. So it's in the grid, it's present twice. So as soon as we find it the first time, we will start a breadth first search from over here, uh, counting off each letter that we have. And if at any point we are stuck and we cannot go anywhere, say we are here at S and the next letter we want is F, there is no F that we can reach from S, so we'll just be stuck over here. So that would be a base condition that would just let us know that we have failed in our task and we should backtrack or go back one step and try to find out what's happening. So basically it's a recursion methodology that we are following. So first we will start over here in this function bool exists. So this just wants us to return if the word exists in this grid or not. The word is given to us and a vector of vector, which is a 2D matrix, is given to us and in board. We start with a nested for loop and check each individual cell if if the starting letter is present or not, which would be a word of 0. And then once we find the starting letter, we check if that starting letter has the entire full word attached to it or not. So we call this function check full word. We send the start position of the starting letter, the board, the word, and the starting index for the word. So the word is a 6 lettered word over here, 6 characters long. So we say that okay, we have to start from the index 0, and in the next case we will go to index 1 and then index 2 and so on. So over here we have a base case for false, where we are checking if the indices are correct, the if I is smaller than 0, or these are basically to avoid character overflow or memory overflow, sorry. So we won't go above or beyond the size of the board. And finally we are also checking if the character at the board is the character of the word that we next need. If any of these is true, then we will return false. And next we are checking if index is equal to word dot length minus 1. This basically means that we have reached over here, say the fifth index would mean that we have found D already, and 6 minus 1, which is the length of the word, the target word, which is 5 again. So if 5 is equal to 5, we will return true. And once we find once these two cases are all not applicable, we will change the board character. So over here, let's say we have found the character A, we will change this character to a hash, because we don't want to go back into this character and check this for another A. Say we wanted to find ABA, and we started from here, we would go A to B, and then again B would search for A, it might go back here, right? So to avoid that, we will be changing this into a hash. Then we check with BFS. So these are basically different function calls, four different function calls. If we are at one place, we if we are at F, we can go up, left, right, or down. So that's what's happening. This one is down, this one is up, something like that. There are four cases, and we are doing or over here, so that if in any one of these cases we get the response as true, we can return true, because we don't care about how many times or if it's uh, true in this or this case. We just want to know if it is true or not, if the word is present or not. Once all of this is done, we have to also change this character back, because in case we need this character in some other traversal, say we are here at C and we have made this C hash, but this C is not giving us any of the right pathways, and this C might, like, we can go from C to E, then we backtrack, go back here, and then we go to E. So that's why we're going to change this from this C from a hash back to a C, and then we're going to return the BFS. So this might have a true or a false, and basically this will keep happening again and again and again till we either reach the base case as false for all of these, or we reach true somewhere. So we run this and we get an accepted. So something that you might encounter if you don't know the solution, if you don't know how to do this specific problem, is you might have a visited array, visited 2D matrix, or and you might not change this letter over here, this character over here. So that would be correct, but the problem would be, because you cannot pass that visited array or matrix by reference, it would take too much time to copy it in each of the recursion stacks, and you would get a TLE, as you can see I have got so many times. So the only way to do this is to change this, like use the board as a visited array of sorts, and then change it back to the character that you have once that processing for that character is over. That's it.